Hothouse Earth. This came out in 2022. It came out on the hottest week ever recorded in the UK, which, if you want to sell a book about climate change and global heating, whenever else would you choose? Perfect. I ordered that heatwave especially. Yes, I'm just saying this came out 22, hottest week in the UK ever recorded, for now at least. I wrote the book because it's now apparent, and has been apparent for some time, that there is practically no possibility of keeping the global average temperature rise compared to pre-industrial times below 1.5 degrees C. You wouldn't believe this because this is all we still hear about, how we need to do that, but it is practically impossible, and I'll explain why in a minute. What this means essentially is that we have to slash emissions, but we also need to adapt to conditions that we know are coming. So we've already crossed what you would call the dangerous climate change guardrail. Locked in is much worse than we see happening on our TV screens at the moment, and we need to adapt to that. I'm going to have to keep up the drinks. I'm just getting over a bad cold, so a little bit dry. Let's look at what's happened over the last 2 years then, which has seen an extraordinary change in the global climate. Last year, the average temperature rise above pre-industrial times was 1.54 degrees C compared to a couple of hundred years ago. That is above 1.5 degrees, but only for 1 year. In reality, last year was probably the hottest since the last interglacial, in other words, before the last ice age. So for something like 125,000 years. If you just look at the last 12 months, up to September, and from last September to this September, the global average temperature rise was 1.67 degrees. So the rate of increase is really quite extraordinary at the moment. And last November, and also this February, on a number of days, our planet was more than 2 degrees C hotter than pre-industrial times. And if we look at the absolute temperature of our world, before the Industrial Revolution, it was about 14 degrees C. Now we are up, getting on towards 60 degrees centigrade, which doesn't sound like much if you consider the weather temperatures from one day to the next, but in terms of the average for the entire planet, it is absolutely colossal. And slightly worrying, there was some research published recently that suggested that pre-industrial times might have been about 0.2 degree colder than we thought. Now, if that's the case, it means the temperature rise is that much higher. So we're really pushing at that permanent 1.5 degree boundary. And the heating rate now is actually pretty much double what it was in the 1970s. I don't know if you're going to see the detail here, especially with the back, but this shows along the bottom here you have a year, June to May, up the side the temperature above pre-industrial, and then you can see the years going up from the 40s, 50s, 60s, all the way up to 2023, 24. And that's a trend that you cannot possibly argue with. The really scary thing is how much last year is above all the other years for temperature. Absolutely astonishing. Now, part of this was the result of what are called El Nino conditions in the Eastern Pacific, which involves a much warmer Eastern Pacific, and that tends to build the global temperature, make it that much higher. But that died down earlier this year, and temperatures are still at record levels. In fact, this July was this summer with the hottest on record. So the heat isn't dying back very much. Where are we now in comparison to the last 20,000 years or so? Well, here's a graph of temperature, years down the bottom back to 30,000 years, 22,000 years. Temperature rise as we come out of the last glaciation. Temperatures fairly static, maybe dropping a little bit, and then shooting up. So anybody you hear talking about things like the medieval war period, they were regional variations, they were not changes in global temperature. This is what global temperature is doing. And there's some key statistics at the bottom there. During interglacial periods, during, in other words, before the Industrial Revolution, we had 280 parts per million carbon dioxide in the atmosphere. Now we're over 420 parts per million. Now, one thing that climate deniers like to say is, well, these are parts per million, that's a tiny amount, it's not going to make any difference at all. And I often suggest to these people that they might want to try a tiny bit of knowledge on nerve agents in their tea one day, if they don't think very small things are important. Or, some cyanide, just one drop of cyanide in your gin and tonic. It's not a matter of concentration, it's a matter of how these gases are able to heat up the planet. So it's their ability to heat that's important. Total amount of carbon dioxide emitted is a bit more than that now. It's 2.55 trillion tonnes. That's how much we've pumped into the atmosphere since the Industrial Revolution. The global average temperature rise as well, it's got a little bit more than that, 1.67 as I pointed out for the last 12 months. So what we're seeing here is unprecedented. But does anyone know when temperatures last went up as quickly as they're doing now in the history of our world, by any chance?
Never.
Yes, that's exactly right. They've never, ever gone up as quickly as they are doing now. Our planet is heating faster than it's ever done before. This is a period, you again probably can't see the details on that graphic at the top, but there's a red arrow pointing at something called the PETER, the Paleocene thermal maximum. That is the fastest we've ever seen the planet heat up before now. about 56 million years ago, this is the sort of world that was around then, 5 to 8 degrees C of heating over 3 to 6,000 years. Now we may well see 3 degrees plus of heating over a couple of hundred years. If we look at the detail, we are, carbon dioxide is accumulating in the atmosphere now 30 times faster than during the PET. The planet is heating more than 10 times faster. So this is we're conducting a unique experiment. We have no idea what the outcome is going to be because it's never been done before. And this is something, to be honest, that you don't really hear about. You never hear governments or corporate leaders or anybody say this is unique. We've never seen this happen ever. They just don't seem that bothered. This is a very scary graph. It is the Earth's energy balance, which is the difference to energy coming in and going out, or heat coming in from the sun and heat going out. It goes back on the bottom 150,000 years. You can see the glacial periods, the blue, and the warmer interglacials are the orange. This graph goes up and down around about zero, so it doesn't actually change that much until we get to about 50 years ago. But that's what it's doing, like I said, 2020. That's what's happened over the past 3 years. This is a positive accumulation of heat within the planet. That's what this is showing. The heat is balanced going in and out, but we're just building up heat at a staggering rate. And that change, critical change, has happened over a matter of about 50 years. So that is extraordinarily scary. And what are we doing about it? Well, there are lots of cartoons about climate breakdown, but this really is a strong thing. It's settled the agreed climate pledge shall not meeting consider changing course of data yet to be determined. Brilliant description of the climate conferences which have been going on for the last 30 years. The last one, as you will know, in a Pecca state. The next one in a Pecca state. Several hundred fossil fuel delegates making sure that nothing happens. Year after year, as these conferences have been going on and becoming media services with 10,000 delegates, emissions have just carried on going up. Yeah, 30 years of COP climate conferences, but no reduction in global greenhouse gas emissions. They just keep on ramping up. And what we need is something much smaller scale, out of the media frenzy, away from fossil fuel delegates, so that something useful can be sorted out. Whether that's going to happen, I doubt very much. It's in Azerbaijan this year, and I don't expect to see anything except people rushing right at the very end to get some sort of communique out that'll say we must stay below 1.5 degrees, or something similar. Now this has got a great deal of information on it. I just want you to concentrate on a few points. First of all, down the side is greenhouse gas emissions in billion tonnes, and on the bottom is the year. Past human emissions are the black line, and if we were somehow to stay below 1.5 degrees, that's what emissions would need to do, 1.5 compatible. Even to stay below 2 degrees, you can see it's almost impossible. Emissions aren't doing this. There aren't any measures in place that are going to make this happen. It's not going to happen. We need emissions to almost be cut in half within 65 months. Now, in theory, it's possible, in the same way as if in theory you've been tied to a railway track and there's an express heading for you. In theory, when it's 50 metres away, you might be able to get out, but in practice you probably won't. So it's not looking good. I hope nobody was coming hoping to hear an optimistic talk. Again, there's a lot of information on here, but what I want to point out is the policies and action graphic over on the left there. That's the temperature rise if policies that are in place today are seen through to fruition. So 2.7 degrees global average temperature rise by the end of the century, could be as high as 3.6, could be as low as 2, which is extremely unlikely. And if you add in tipping points, positive feedback effects, then you get up to 4 degrees C and above. Tipping points are elements of the climate system that start to change very rapidly. And once they start to change, there's no return. In other words, if the Greenland ice sheet starts to melt in earnest, even if we bring carbon emissions way down, it won't make any difference. And we're very close to a number of tipping points already. There are a few outlined on here. This is a range of tipping points that can happen at different temperature rises, but the key ones are abrupt thawing of permafrost at high latitudes, collapse of the Greenland ice sheet, collapse of the current known as the subpolar Gaia, which is part of the Gulf Stream and that set of currents, and the collapse of the West Antarctic ice sheet. All these occur below 2 degrees C. The collapse of the West Antarctic and Greenland ice sheets occur around about 1.5 degrees, but possibly as low as 1. So we may already have passed those tipping points. So one of the ideas that a lot of politicians come up with these days is, it doesn't matter if we go past 2 degrees or whatever, because eventually we'll have all this technology to suck carbon out of the air. Well, it won't make any bloody difference by then. Fine if you don't mind a 12-metre sea level rise or whatever, ultimately. But if tipping points tip, then that's them tipped. You can't go back. So let's look at a few of these. Let's look at the poles, for example. What's happening there? They're heating 4 to 5 times faster than the planet on average, and 6 times faster than they were in the 1980s. To give you some idea of how much ice is melting, 7.5 trillion tonnes of ice was lost between 1992 and 2022. That's at both poles. Greenland is shedding 400 billion tonnes of ice a year. Antarctic melting increased threefold from about 76 billion tonnes a year to 219 in just a 5-year period in 2012 and 2017. So these numbers are mind-boggling, really. And of most concern is that some of the glaciers now in the East Antarctic ice sheet, which is that whole huge area on the right-hand side of that map of Antarctica, Antarctica, that image of Antarctica. You can see the mountains in the middle. There's a West Antarctic ice sheet and the East. The East is starting to show signs of instability as well. If all that melts, then you're looking at 50, 60 metres of sea level rise. One of the glaciers that people are most concerned about is the Thwaites Glacier, which is moving very, very rapidly. If that collapses, then alone that will raise sea level by getting on to 2/3 of a metre. And an ice-free Earth would see the sea about 60 metres higher than it is now. That would bring the sea into Derby, just about. So, you know, it would be, most of the east of the country would be underwater. That's not going to happen for a long time. I mean, it's not that depressing yet, anyway. If the ice is melting faster, then we should see that in sea level rise. And we do see it. These are sea level rise in millimetres down the side, years on the bottom. You can see between 1910 and 1990, sea levels only going up about 1.5 millimetres a year. But then as you narrow down the measurement windows, the rise gets higher and higher and higher until you get to 2014, 2019, and it's going up by 0.5 centimetre a year. Now that might not sound like a lot, but it's suggesting a doubling rate about every 20 years or so. And if that's the case, then you're going to see, by the end of this century, getting up to 2 metres of rise. I'll go back. To give you an example of what 2 metres of rise means, in Sheffield, it means bugger all. But if you live in Boston, or if you live in Spalding, the sea will be at your doorstep with 2 metres of sea level rise, because it's so flat in parts of eastern England. At Cambridge, under 2 metre rise, would be close to being a seaside resort. Now another concern, another one of these tipping points that happens around about 1.5 degrees, maybe less, is an abrupt thaw of high latitude permafrost, Siberia, Arctic Canada, etc. The reason why this is concerning is that the permafrost holds beneath it huge quantities of methane. And methane is, over a short period of time, 86 times more effective than carbon dioxide, over say 20 years or so. So adding vast quantities of methane to the atmosphere is exactly what we don't need at the moment. One estimate is that there's nearly 1.5 trillion tonnes of methane locked up beneath submarine permafrost in the Arctic, because the seabed's frozen as well as the land. One of the concerns is that you can get these enormous bursts, as they call them, methane, occurring over a matter of weeks or months. And it has been suggested in one or two papers by some researchers that you might get bursts of up to 50 billion tonnes. That's a lot of methane. In fact, not only is it a lot, it would increase the atmospheric methane content by 12 times, almost literally overnight. And that, the effect on temperature, on global heating, would be to bring it forward by 30 years. So you would instantly be transported from now in terms of the climate to mid-2050s. Now this is by no means certain. It remains controversial for a number of reasons, mainly because climate scientists looking at previous periods of rapid warming, in interglacial periods for example, don't recognise this sort of event happening. But the absence of evidence is not evidence of absence, so it's still up in the air whether this is going to happen or not. But the fact remains that increasing quantities of methane are leaking out of the permafrost anyway, as it thaws. So this is happening, it's just whether you can get these enormous bursts or not that's up for debate. Now this is probably the most worrying consequence of global heating at the moment. There is a system of currents, including the Gulf Stream, in the North Atlantic that keeps the UK and Northern Europe much warmer than it otherwise would be, if you compare temperatures with the other side of the Atlantic, Labrador, etc. It's called the A-block, which is the Atlantic Meridional Overturning Circulation. But I'm normally just talking about the Gulf Stream Now this whole system of currents is at its weakest for at least 1,500 years, and possibly 11,500. That's right back to the end of the last ice age. And there's increasing evidence of instability. There's a lot of research going on the Gulf Stream, or the AMOC as it were, and what it's going to do. If you look at the IPCC reports of several years back, they all said, well, it'll slow down a bit this century, but that's about it. Well, that isn't what most people think is going to happen now. There are quite a few papers that have been published recently. Latest is that shutdown can occur from any time between 2025 and 2090, with 2050 as a central estimate. There's a later paper out actually which suggests it could happen as soon as the 2030s and is more likely than not to happen by 2050. That's no time at all. This is a hugely catastrophic event. It's mind-boggling that something like this is on the horizon and nobody's doing anything or even thinking about it at all. It's just staggering. I mean, shutdown would result in a 3 degrees C drop in temperatures across Europe. That doesn't sound much, but it is huge. It's much bigger than we saw in the so-called Little Ice Age, for example. You will get some sea level rise all along the east coast of North America as the water backed up. The whole current starts to stagnate and the water begins to back up. And there are huge knock-on effects on global weather. So this is the most imminent of all of the threats, I think. And it's still not certain exactly what the implications will be for the UK and Europe. There was one piece of research I was thinking a long time ago, and I don't know how good the research was, but it talks about studying a lake in Ireland which froze the last time the Gulf Stream and associated currents, the AMOC, shut down. It froze over a matter of months, and it seemed to have stayed frozen for 85 years. So the consequences might be slightly worse than we're budgeting for at the moment. Now, everything I've talked about so far has been about physical consequences, but the greatest issue with climate breakdown is that it's a threat multiplier. It makes worse things that we've already got at the moment. It makes, it's affecting weather, it's making it more extreme. It's causing famine and food security issues. It's affecting health, mental illness, war, civil unrest. All these things we've already got will be made worse by climate breakdown. Extreme weather, we see it now every single day on our TV screens. So, it needs no introduction really. It's just a matter of choosing which particular bits of extreme weather I want to show. I mean, it's extraordinary how global heating has translated to this in the last couple of years. So it's been supercharged really, and most notably we're seeing extreme rainfall, we're seeing floods, heat waves, droughts and wildfires. They are the shock troops, if you like, of global heating. And now we can actually pick, or we can select a particular incident of extreme weather and say if it was more likely to be caused by climate change, if it was made worse by climate change or whatever. It's called attribution analysis. And these are the results of looking at 500 extreme weather events up to 2022. Nearly over 2/3 were more likely or made more severe due to global heating. 12 events would be impossible without global heating. 1 in 3 summer heat deaths all the way back for 30 years are attributed to global heating. That number's in the millions. So millions of people have lost their lives already because of what we're doing to our planet. And in fact, the fingerprints of global heating stretch all the way back to the Dust Bowl conditions in the US in the 1930s. Food. This is the scariest of all, probably. I mean, 800 million people go to bed hungry now. In the 1980s, there were around 50 food emergencies a year. Now there are more than 30. Obviously, this is all caused by climate breakdown, but all sorts of other issues as well. But its fingerprints are all over this. Agricultural productivity is down about 20% since 1960 on what it would have been if global heating wasn't happening, if climate breakdown wasn't happening. scariest statistic of all. By 2050, the world will need 50% more food if numbers keep developing as they are, but crop yields could be down 30%. That's a halving of calories on average per person on the planet. So think about that. We won't be immune to this sort of thing. I mean, this year, the grain harvest in the UK is 13% down because of floods and extreme rainfall last year. It's likely to be worse next year. I mean, places, some of the counties this year, Bedfordshire, Oxfordshire, saw the most extreme rainfall in any month since 1836. And that's when records began, so probably ever. Heat. We know global heating is associated with heat, but we haven't seen anything in this country yet to compare with how bad it can get. A combination of heat is measured on an ordinary thermometer, but a combination of heat and humidity is measured on a wet bulb thermometer. I'm not going to go into the details of that now, but a wet bulb temperature is always lower than a dry bulb temperature. If you get a wet bulb temperature of 35°C, it means that the humidity and temperature together are so high that the body cannot sweat. So with that temperature, your body just heats up. Doesn't matter if you've got lots of water, if you're in the shade, if you're fit, makes no difference. If you don't have access to air conditioning, you have 6 hours to live. There's no respite without AC. Now this has already been seen increasingly, these conditions in many parts of the world, Australia, Mexico, particularly the Gulf, South Asia, Pakistan, India, etc. But you're going to see increasing incidences of these conditions over the same areas, to start with at least. I mean, we're not going to see this in the UK, not for a very long time anyway. But probably the worst, or most at risk area is the northern China Plain, which is an agricultural region. It's the breadbasket of the country. There's 400 million people working there in the fields. Very humid because of all the irrigation. No access to air conditioning generally. One day of these sorts of conditions and you're looking at death tolls of millions, tens of millions in the years to come. So these humid heat waves are very worrying. I wrote an article about this in Focus magazine, Science Focus actually, I just remembered last month, if you happen to take that. Now, most defence requirements, certainly in the US, I'm not sure if the UK have really thought about it yet, but many of them are certainly already about the impact of climate breakdown on the stability of nations as they compete for water, food, land, as they try and cope with mass migration, different from anything we've experienced yet, and fight over resources. And I'm just showing one example here of an area of conflict, which is the area around the North Pole, where sea ice is beginning to disappear very rapidly, where northeast and northwest passages are opening up for trade, and already oil companies, unbelievably, are looking to move into these and suck out more oil and gas so they can raise temperatures even further. Lots of mineral deposits in places like Greenland, not surprisingly in Canada, the United States, Russia, and other countries are all getting ready to exploit those, and they will come into conflict because of that. But the area probably most concerning in terms of future conflict is Southeast Asia. And this is largely down to the rivers, which all, nearly all the major rivers in Southeast Asia drain the Himalayas and Tibetan Plateau. Now, with business as usual, you're going to lose something like 2/3 of the glaciers by the end of the century. A third will be gone even if we keep below 1.5, which we won't. So, the Indus, Ganges, Mekong, Yellow, Yangtze, all provide huge quantities of water, enough to irrigate the fields and provide food for 2 billion people. And these, by mid-century probably, will be a problem because of flooding rather than anything else, because the ice will be melting at an ever more rapid rate. But beyond mid-century, the rivers will start to fail as the ice disappears. So you will have widespread harvest failure because there won't be the water, there won't be the irrigation. And obviously the global temperature is ramping up all the time. You'll have power losses, so air conditioning is going to suffer because many of these rivers are dammed, and those dams like Three Gorges, for example, are providing huge quantities of power. Well, as the level of the water drops, that will no longer be possible. So there's going to be huge competition for the remaining water resources. You're talking here about Pakistan, India, China, all nuclear powers with nuclear missiles. So this is quite a worrying situation. Societal breakdown. These are all things people don't even want to talk about. I'll explain who this guy is in a minute. Some of you may know. Accelerated climate breakdown will translate into massive, persistent social and economic shocks. This is just me saying this. There have been lots of studies in just the last year looking at how it will impact upon global GDP and how that will collapse. So this is a big thing at the moment. Extreme weather, as I've said, is already significantly impacting on crop yields and food supply. If you notice that chocolate is much more expensive to buy, or coffee, or wine, all these things are being significantly affected already. Extreme weather losses are expected to cost $38 trillion a year by 2050. That's about a third, I think, of the global domestic product, GDP. The UN has told us 345 million people now marching towards starvation. That's not going to get any better. Now, the Human Development Index, which measures progress in inverted commas, and has always been going up, has now started to drop in the last couple of years. And this isn't just developing nations, this is here and in the US. There was an article today showing how, well, two articles, one showing our generation is much less healthy than the previous ones, and another showing how life expectancy is falling in the developed world, particularly in the United States. So everything's pointing downwards. And the reason I have this chap on here is that he was famous for really just one thing, and that is saying there are only 9 meals between mankind and anarchy, or 3 in my case. You know what he's getting at. Just imagine now if you don't have any food, you can't get food for 2 days. You're not going to go to work, are you? So the factory's going to shut down because you're going to be trying to get food from somewhere. And it doesn't take very long for everything to start falling apart. This is what nobody wants to hear. This is an update, and there have been 2 in the last couple of years, to the limited growth model, which was developed in the 1970s, but is still absolutely relevant today. And it predicted societal collapse sometime in mid-century. That isn't really changing. US National Bureau of Economic Research suggests for a 3-degree C rise, you'll see a 50% fall in output, capital and consumption of the world by the end of the century. A Nature study last year, average income is down by almost a fifth in the next 26 years compared to without climate breakdown. For a business as usual scenario, that would be 60% by the end of the century. There are lots of these, I'm just giving a few examples. The Institute and Faculty of Actuaries in the UK, now this is a pretty conservative body, you know, they're not going to start getting panicked or whatever. They talk about 50% destruction of GDP by 2070 and 2090. But governments are just pretending none of this is actually out there. It's extraordinary. The limited growth update I mentioned at the beginning predicts societal collapse as soon as 2040, starting as soon as 2040 for a business as usual scenario. That doesn't surprise me at all, looking around us and seeing the sort of things that are going on. Now, where is our planet going? Where is our planet's climate going? This is a little bit of a complicated graph if I explain the key bits for you. Time is coming towards you. Cold is blue, hot is red. There's our planet at the beginning of this interglacial. Now, it should follow a straight path that comes all the way along to where it's a stabilised Earth. That's where we should be going in the last 12,000 years or so. But our planet's been going instead down here. And we're at a point now where if we don't do something desperately soon, we're not going to get to that stabilised Earth. We're not going to get back on track. We're going to go down here, Hothouse Earth. So things cannot be more critical than they are at the moment. A couple of years ago, Jim Henson and others, he's probably one of the most well-known climate scientists. He's been out on a limb before, and he's been proven right time and time again. Him and his co-authors estimated what the global average temperature rise would be if we burnt all fossil fuel resources. And that rise would be 60 degrees C. Now, I mentioned earlier that our planet at the moment is about 15.9 degrees in terms of its average temperature. So this is taking the average temperature of the planet, day and night, winter, summer, right through the year, just over 31 degrees C. That is going to make most of the planet uninhabitable for all sorts of reasons, not just the heat, but because you won't be able to grow crops, there won't be any water, etc., etc. So it's not entirely an existential crisis. It's very difficult to wipe out 8 billion human beings. But this is, if this happens, then you're going to see a huge culling of the population down to hundreds of millions at the most. Maybe much, much less than that. And on that happy note, I'll finish. But just William Wilberforce said this a long time ago about slavery, and it's just so important for people today listening to this sort of thing. You may choose to look the other way, but you can never say again that you did not know. We should all know this. We all need to know what the reality is, otherwise we just won't accept the urgency and we won't act as we should. Thank you very much. Thank you.
Very much. Well, I think we all need a little bit of a break after that, don't we? So, we're just going to take 5 minutes if you need a bathroom break or you want another cup of tea, and then we're going to have some questions and answers. So, think of your questions, and we'll be back in a few minutes. Can we have another round of applause for our speakers?